In this video, we're going to come up with a simple understanding of what electricity is and tie our understanding to some of the principles that we learned in the atomic theory section of the chemistry unit. We start from the foundation that all matter, everything that has mass and occupies space, is composed of atoms, and atoms are made of three subatomic particles, two of which have charge. You recall from the atomic theory unit that protons, which we find in the nucleus, contain positive charge. Each proton has a positive 1 charge, so this atom here with 9 protons would have a nucleus that has a charge of positive 9, while the subatomic particle that we find in the shells around the nucleus, electrons, each have a negative 1 charge. So if we count the total number of electrons, 2, 4, 6, 8, 9, we see that the electrons have a total charge of negative 9. Now, in this case, we know that this atom is neutral because the number of protons, meaning the positive charge of the atom, and the number of electrons, the total negative charge of the atom, are equal. And if we do some simple math, positive 9 minus 9, we see that this atom has a charge of 0. However, what we want to know is where electrical charge actually comes from. Now, electrical charge occurs when the number of protons and electrons within an atom is no longer equal. So if the number of protons and electrons are unequal within an element, usually by completing the valence shell, we end up with an ion, also known as a charged atom. And we can see two different examples of ions that form with the elements sodium and chlorine. Sodium as a metal, we know, has a relatively small number of electrons in its valence shell. It only has 1, which means if it wants to form an ion, it can lose this 1 electron that it has here, or it can gain 7. Now, losing 1 is obviously easier than adding 7 in, so this is what's going to happen to sodium, and when it loses 1 electron, it loses a charge of negative 1, meaning that its ion has a charge of positive 1. And if we count the number of protons and the number of electrons, we see that this is confirmed. So we know sodium has 11 protons because it is atomic number 11. And if we count the number of electrons in the ion form, 2, 4, 6, 8, 10. So positive 11 minus 10 equals positive 1. So we can see that sodium now has electrical charge. Ions that, like sodium, that have a positive charge are what we call cations. Now, one question is, when sodium loses its electron, where does it actually go? Well, as it turns out, sodium, instead of just making this electron disappear, can actually transfer this electron to other elements like chlorine. Because if we look at chlorine's valence shell, it has 7 valence electrons, and if it wants to form an ion with a full outer shell, it needs to add 1 electron to its valence shell. And when we add 1 electron, we are adding a total of negative 1 charge, giving chlorine's ion a charge of negative 1 as we see. So because chlorine is a negatively charged ion, we don't call it a cation, we would call it an anion. But the most important thing for our study of electricity is actually understanding this movement of electrons, because this is the source of electrical charge. So ions form because electrons can actually move between different substances, as we see from sodium losing its valence electron and giving it to chlorine. And the movement of electrons is easy to predict on a fundamental level, because the movement of electrons is based basically around one simple saying, and that saying is that opposites attract. More specifically, substances that have opposite charges. So if we were to have, like we have up here, a cation with a positive charge and an anion with a negative charge, these substances have opposite charges. So let's go ahead and use that as a reference, a cation and an anion. Now, based on the principle of opposites attract, cations and anions with opposite charges will attract to each other, causing them to move closer to each other like this. And this is what we call attraction. Now, the opposite is true if we're dealing with two cations, that being two ions, both with positive charges, or two anions, that being two atoms, both with negative charges. In both of these cases, these are substances with identical charges, or identical probably isn't the best word, with similar charges. Similar meaning that they both have positive charge or both have negative charge. We don't really care about the magnitude, whether it's +1, +2, or +3. As long as two substances have both positive charge or both negative charge, they will do the opposite of attracting, which is the verb to repel. And when two substances repel, they move farther away from each other like this. And this basic understanding about how charges move towards each other if they are opposite and away from each other if they are similar is the foundation of our understanding of how electricity works. Now, practically speaking, there are two different types of electricity, both of which you can observe in day-to-day life. So we can see this girl's hair is attracting to the outside of this balloon. So when negative charge, and remember that all negative charge comes from electrons, this attraction here is caused by the accumulation of negative charge, meaning that electrons are collecting in a high concentration here. And when the electrons stay, at least temporarily, in the same area, this is what we call static electricity, because the electrical charge does not move until it is given somewhere to go. So the reason why this attraction occurs is because this balloon is temporarily charged with a lot of electrons that were absorbed by the balloon, thereby attracting to the positive charge that we find in this girl's hair. However, the type of electricity most people are used to is actually represented in this picture here. So this is a structure that we call an electrical circuit, and if you think that the word circuit looks and sounds similar to the word circle, that's because they share the same root and a similar meaning. So in this situation, unlike static electricity, where the electrons are concentrated and basically remain in the same location, in a circuit, the negative charge, the electrons, is constantly moving, and this is what we call a current. And so to visualize this, if we actually draw on the electrons here, unlike static electricity, these electrons would be moving between the different ends of the battery through this connecting wire, and these electrons will never stop moving. And this is what we call an electrical current, also known as current electricity. In the next video, we're going to investigate where static electricity comes from and look at the behavior of objects and how to induce static electrical charge.